Okay, so we have a rectangular uniform plate that has we have a weight of 75 pounds. Okay, so uniform means that the weight is in the middle. I like to draw my diagonals to find the middle. So that's the weight, and the weight is just on Z. We go that the weight and the distance, so that's 20. So we have 10. And from the axis X, that's 38 total. So 19. And that's inches and inches. And keep it everything in inches. You don't have to change that. There's some dimension that we don't need. This one, it's not for this problem. Okay. And the question is, what is T? The tension in the cable. Okay. If we look at the 2 inch, the instruction tells that the inch B does not exert any axial thrust. Okay, we cannot have both of them having some axial thrust. So just the axis A. So this one will have 1, 2, and 3, and this one will just have 2. Okay, we will just solve for T. So doesn't really matter which one is which one, because we will use just one equation, so we will be able to find one equation. Let's look at the equation that we will use, because all the forces there are on the axis y. Okay, so if we do the moment about the axis y, sum of the moment about the axis y equals 0, what do we have? We will have the w, right? That's 10 to rotate in the positive direction, so plus the w at the distance of 10. And we will have t, and t has 3 components, one on y, one on z, one on x, and one on y. Let's me trying to draw it. It's going a little bit in this direction, so a little bit there. But the only component that tends to rotate about the axis y, because the point E is a line there, is the tz. So we will have minus the tz, the complement tz, this one, times the total distance, that is 20, and it's equal to 0. Okay, so basically we need just to find the complements of the tension T on Z. Okay, let's write this. So to find the complement of T, we will use the 2 points. Okay, the point E and the point F. Point E and point F. And we will use the vector position, and after that the unit vector, and after that the Cartesian notation form of T using the unit vector. So we have the point E. What are the coordinates of the point E? So that's the 0, okay? So X is 20, Y is 30, and Z is 0. And for the point F, on X we have 0. On Y, F is completely on the corner there, so 38 and 25. Okay, so we have R. T is from E to F, so let's look at REF. It's equal to, oops, let's move it, this one a bit there. So REF, it's F minus E, F minus E, F minus E. So it's minus 20 on I hat, plus 8 on J hat, and plus 25 on K hat. Okay, that's my REF. Now the magnitude of REF, it's the square root of 20 square plus 8 square plus 25 square. Is it an exact number? Let's look at this. So we have 20 square plus 8 square plus 25 square, and I forgot to take the square roots. 33. Yes, that's awesome, inch. So to take the unit vector, we take the vector position, and we divide each complement by the magnitude of REF. So we got UEF as a vector, that is equal to minus 20 divided by 33 I hat. So I take this one divided by this one, plus 8 divided by 33 on j hat, and plus 25 divided by 33 on k hat. So the vector t it's equal to the magnitude of t time, it's a scalar time, UEF. I multiply a magnitude by a vector. Magnitude, direction. So that gives us minus 20 divided by 33 t on I hat, plus 8 divided by 33 times t on j hat, plus 25 divided by 33 t on k hat. And this is, everything is bound. So we have our complement on z, that's this one, 25 divided by 33 t. So now we can replace the value tz inside this equation. So we have w is 75, so we have 75, the weight, times the distance 10, minus 25 divided by 33 t times 20 is equal to 0. So we have t that is equal to, let's be one step at a time. Let's be two all the steps at the same time. So we have 75 times 10, and now we need to inverse this. So 33 divided by 25 times 20. So t is equal to 75 times 10 times 33 divided by, don't forget the parentheses, 25 times 20 on the bottom. Oops. 49.5. T equals 49.5. And that's pound. That's the same unit than the weight. And that is, we have our T. We have our tension in our rope. Just by using the moment about Y, because that's the only, the two only complement that make, the two only forces that make the the plate rotate about the axis Y is the weight, 25, and just the complement on Z of the tension. For the inches, all the forces on the inches are aligned or going through the axis Y, so they don't create any moment. And again, for T, we have three complements of T. Let me clean this a little bit. So we have TZ that tend to rotate about Y. We have a T ax that do not rotate about Y because it's going through the axis Y. And we have a little Ty that is parallel to Y, so it doesn't rotate about the axis Y. That's why we just take in account the TZ complement for the rotation and the weight that's tend to rotate in the other direction. So that's it for this example. That was faster than we thought, right? Bye-bye. See you next time.